what did we collect so far? A famous IPv4. Let's say just that Sajjad just provided this IPv4 for us. Just provided the IPv4 for us. And in order to start a real work, he also provided its subnet mask. All right. So example number 1. If you ever had encountered an IPv4 that looks like 192.168.0.1, and if you ever saw or encounter, let's say, the completion of the subnet mask with 24, what should I do? What should this result to me? What is the benefit of it? Let me start. Now, step number 1 of understanding this IPv4 is to write, let's say, this IPv4 in the binary language. Well, it's subnet mask, I'm sorry, in the binary language. It's 24-bit. All right. So 1 bit, 2, 3, 4, 5, 6, 7, 8 bits, and it's always fixed. Every 8 bits there is a dot. 9, 10, 11, 12, 13, 14, 15, 16 bit, 17, 18, 19, 20, 21, 2, 34 bit, done. What should I do after that? Should I cry? No. You should just finish the 32-bit that you have to fill. You are forced to fill that with a non-value digit, which is the 0. Done. So this is step number 1. Good. Step number 2. Do you remember the total volume of a subnet mask? Yes, it was a 32-bit. Well, a 32-bit is a mix of ones and zeros in this case. That is correct. So the 32-bit minus the 24 bits that are already coming in the subnet mask results in 8. Is that true? That is true. Also, 8 is the number of zeros in here. Not a coincidence. This is the truth. All right. What you should do right now is that you should refer to the rule that says to the origin of the binary language up to the number of zeros. Up to the number of zeros leading to 2 to the number of 8 equals 256. Wasn't that the amount of IPs in the octet? No. We are starting something new today. We are starting a technique called the VLSM, where from the subnet mask, I can understand the number of IP addresses within a single network served by this IP, by this network. What should that mean? It will be clear to you in, let's say, 3-4 minutes. But right now, let us stick again or go back and review the steps. Step number 1. Step number 0 is having an IP and a subnet mask. Done. They have been provided already in the problem, in the case, in the scenario. They have been provided at the beginning of the paper. No problem. So this was 0. Step number 1. Write it in the binary language. Let him. Step number 2. Deduct the bits of the subnet mask from the total length that is fixed. The 32 bits are fixed. Is the subnet mask fixed as well? No. It depends on the problem that we have. Today's example has it with a value of 24, but it can range from 8 to 32. So step number 2, I did a deduction. The result was 8, also known as the number of zeros. Step number 3, how about you take this number of zeros as a power for the base of 2, like an algorithm, log 2 to the power, let's say log 8 to the power to the base of 2. So this will result in 256. Now 256 as an acronym is the total number of IP addresses within one single broadcast domain, also known as one single network, also known as one single domain, also known as one single subnet. What does that mean? It means that if I had a network of almost 250 computers, have you ever finished the middle school, high school, at, let's say, someone. We do that. We did that a lot often when we were teenagers. I don't know about you, or I don't know about where you live or what you did at that time. But we used to, let's say, finish school at noon, sometime ranges between 12 to 2 p.m., and then go to a network station. In the network station, we do nothing networking. We were kids. We used to just find some 8, 10, 12 computers all interconnected together, and we can play whatever video games. And between us, we are the opponents, one with the other, either playing co-op together on the same side or one against another, have fun, playing, let's say, a football game, playing something like a Red Alert, Counter-Strike, whatever you are playing. Nowadays, there are so many modern games on PS5, PC, Xbox, etc. Same idea, but we used to do that on desktop computers, talking about the very beginnings of, let's say, the 21st century. I used to do it like some 2005 and 6. I'm not that old. I'm really young, actually. I still haven't touched 30s yet. Haven't reached 30s yet. I'm still in my 20s. Okay. So the idea again is that it was a network. How were these computers interconnected? How the network was established? So there was a connection between them, and there was a broadcast domain having all of them under its umbrella, having all of them within itself, that domain, by using IPv4. Which IPv4 exactly? Regardless of the number, the numbers are of billions of possibilities, millions of possibilities as well. Let's say it more specifically. They are of millions of possibilities. The super most single important thing here about this design is that these IPv4 addresses should be of the same domain. When I used a 192.168 0 dot something /24, I just understood today, based on today's lessons, that this IP alongside with this subnet mask can give me up to 256 total number of IPv4 addresses that are usable within a domain. Usable within a domain. Now, before I proceed, because this example has two papers, this is paper number 1 that I need to take a screenshot for it. This will be very important. We say click, control save, screenshot number 4, done. And for number 2, if I wanted to proceed, I just need to make some space for myself. Let me keep the first ones. And understanding this as a total number of IP addresses should result to me in the following. Should result to me in the following. The following is as follows. Is that this network starts from 192.168.0, and it has to start from the very first possibility this time as a network itself, 0. And that it has around 256 possible addresses, also known as the total number of IPv4 addresses within the domain. So if I asked you again, I know that you will answer it correctly, but if I answered you again, if Sajjad has almost 300 fingers and he wanted to start counting 256 values, starting from the very first finger, which has a value of 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, until 3 hours later, until I reach 255. The 256th finger will have the value of 255. Where did the number of 256 come from? Comes from 2 to the power of the number of zeros in the subnet mask, because it shows me what's left, the amount of flexibility, the space that is left in the subnet mask. The area of zeros are the area of flexibility, the space of numbers that can be filled, while the area of ones is a fixed thing that you cannot touch. And it will has other names that I will call before ending this video. This will be super important to understand. So starting from zero, by the way, you start the increments in IPv4 from right to left, right? Maybe the camera is opposite, is reverted here, from right to left, meaning that I can only, and I should, and I only can start changing this from the right octet, from the very first right octet. So start increasing numbers to mean from the 0 until you reach the 256th value. This will definitely be 255 for two reasons. Because math, reason number one, and two, you can never see in your life a number more than 255 in an octet. Today's coincidence has reached us or took us to 255. So this is the very, very first IP. And this is the last IP that you can ever see within that network or broadcast domain or subnet. Are these IP addresses usable? No. Why? Because the very first one has a naming called the network ID, not to be used on computers, to be understood as an identifier between the network components only. You will not touch it. The last IP in that domain is called the broadcast ID, not to be used on computers, to be understood as a type of broadcast identifier and exchange and discuss between network components when you study routing on whatever course, a CCNA, Juniper JNCIA, Huawei at CIA, Cisco CCNP Enterprise Core, let's say in these courses, you will understand what I am talking about in the network ID and the broadcast ID. Do I have such courses? Of course, just go and navigate the channel. You will find a lot of free courses, free content, hundreds of videos for free, regardless of the paid content that I have in English language, of course. So yes, the CCN is on the channel as well. But I'm just talking about IPv4 design in a more detailed as well as simplified method in 2023. Again, these two addresses are not to be used, but these are just two addresses out of 256 possible address. So this leaves to me 254 usable IPv4 addresses. Which are these? They start from the very first IP of the after the network ID, 192.168.0.1, and they end up in the last IP before the broadcast domain, 192.168.0.254. The yellow guys, the 254, yes, I mean 192.168.0.2, 192.168.0.3, 192.168.0.10, 192.168.0.25, and until we will count until we reach 192.168.254. These are the usable IP addresses or range. So from the very first example, I understood a network having the IP, also known as the subnet, also known as the prefix of 192.168.0.0 over a subnet mask, also known as the mask, also known as the prefix length of 24, is a network, is a broadcast domain, is a subnet that contains a total number of IP addresses which equals 256. The very first and the very last of them are not to be used on computers, on beneficials, for end users, for end devices, for equipments of humans to be used, computer, laptop, server, IP camera, print, access point, mobile phone, laptop, whatever, they are not to be used. But what is left of that domain between these two numbers, which starts from 192.168.0.1 to 192.168.0.254, is the usable. So a network of a 24-bit mask, subnet mask, allows me to have a network, a small local area network LAN of 254 computers interconnected using some switches between them, and every single computer will be able to communicate, contact, and see every single other computer in the network. Before I finish, before I say goodbye, just before I forget, to be honest, actually, this diagram here is built of something called the network portion and something called the host portion that we will talk about when we start other examples in the next lesson. I hope that you have made the benefits so far from the course, from the video. Let me see your comments in the description before we proceed with the other videos, and I hope that you are enjoying yourself with me. Thank you.